So I will continue talking about the organization model, and this is something that you actually also indirectly referred to. I mean, the colleague here in the front row. So the organization model organization models are also located at the analysis level and at the interaction perspective, because they deal with relationships between roles. So they are located in the same place as role models. And organization model, so as I already said, I mean, it's basically represents the kinds of relationships between roles of a socio-technical system. And there can be different kinds of relationships. And here are some typical relationships, but this list is by far not exhaustive. So there can be other types of relationships. And in your models, when you start modeling the organization for your system, then if none of these types here works for you, then feel free to choose your own type or invent your own type. But these classical types of relationships is controlled by. So this is a relationship between a boss and his subordinates, like we are here all controlled by the vice rector Alar Kolk, who is our manager, our boss for this summer course. Then there is the relationship type is benevolent to, and this is a typical relationship between self-interested roles. So it's a typical relationship between customer on one hand and service provider on the other hand. Why? Because a service provider is always benevolent towards a customer, in the sense that a service provider satisfies the request for service if it is in its own interests to do so. But a service provider may also say no. If it's not in his interests, or maybe if a service provider has run out of commodities, then a service provider may refuse the service. So this is the very reason why we use this is benevolent to relationship rather than provide service to. Of course, one can use provide service to as well, but is benevolent to is more precise, because it also represents the option for refusing a service. Then there is pied to, between equal roles, like between patients or pregnant women in healthcare related information systems, or between drivers, or between shoppers, or between students in some kind of social networking system like Facebook. So this is a relationship between equal parties. And then there is another one, it is a dependency for some resource. So it is a relationship between me, for example, and the catering facilities here, which can be viewed as an organization, because relationships can be between roles. So I'm playing the role of a lecturer, and the catering organization is playing the role of caterer here. So, and there is this dependency for resource relationship between us, because I depend for their services, because I don't have time to go outside to the canteen, so I depend on the services by the catering here on the spot. And these three dots mean that there can be other kinds of relationships as well. And examples are again very simple. in the case of the Tamagotchi case study, the Tamagotchi is controlled by its owner. So I think it's self-evident. It's controlled by its owner. On the other hand, a Tamagotchi is paired to a friend Tamagotchi. So if I connect to Tamagotchis and they go to visit each other, then they are at the equal level. So they are peers to each other. And then there is this kind of interesting relationship. This is aggregation, as you probably have recognized already. So I actually use UML style notation quite a bit. And it is not UML, but many elements of this notation, they come from UML. So, and this means that the matchmaker role forms a part of the My Tamagotchi role. And this kind of splitting into component roles is in many cases is very useful. And by the way, it is aggregation. It is not inheritance. So it is different because this matchmaker does not inherit the responsibilities and constraints of My Tamagotchi, but it just forms a part of this role. So this is the difference between inheritance and aggregation. So we understand it if I explain what the matchmaker does. So the responsibilities of the role matchmaker are actually to find a partner for My Tamagotchi. If My Tamagotchi is of appropriate age and hasn't found a partner of the opposite gender, because Tamagotchis have genders as well, then the matchmaker will intervene and will start proposing possible partners from among the Tamagotchis that my Tamagotchi has interacted with. Because in my Tamagotchi's lifetime, well, I actually expose my digital pet to many other digital pets. I mean, like for example, as a kid, and other kids, I mean, they have their Tamagotchis, so then they interact with each other, and my Tamagotchi keeps list of these acquaintances, and then if no partner has been found, then the matchmaker enters the scene and starts proposing a suitable partner from among these Tamagotchis that my Tamagotchi has interacted with. Then about grocery shopping, the relationships are, first of all, is peer-to between customers, which is, I think, self-evident. Then is benevolent to between store and customer. Store is benevolent towards the customer because a store is a service provider and a customer is a consumer that uses the service. Then customer controls his or her assistant. So there is a control relationship. My assistant that recommends me the places I should go for shopping, I control it. And then there may be a coordinator role. And then the assistant is paired to coordinator. Coordinator actually is the one that stores centrally information about different stores, about prices, qualities of service, and so on, and then shares that information selectively among customers. So, and basically that's it. There was not all relationships were covered here, so I didn't have here an example for depends for resource relationship, but I provided my own example. And by the way, a resource can be a physical resource like food in the case of my example, or can be also an information resource like some piece of knowledge that I need to know in order to perform my activities. Okay, and now, as I said, so we are going to have a teamwork that will be combined with a short break because of this time pressure that I feel more and more here. So what I ask you to do is I'm asking you to create role models for the product idea of your team. So the role models where you represent your roles that actually you have already, in most cases you have those roles already attached to your goal models. But now I ask you to represent, model these roles in terms of their responsibilities and constraints. And please don't forget also the role name in that table and the short description for your roles. Just create role models as tables for the product idea of your team. And then after that, create organization model for the product idea of your team. And I think in most cases, these organization models are going to be fairly simple, just showing relationships between the roles. And the relationships can be then is controlled by, is benevolent, dependent for resource, or something else according to your own choice. And please use for this purpose an A1 paper, so that it would be comfortable to give a presentation later on today, or a word processor of your choice, because this is just about creating tables. And if time allows, continue working on your goal model. And I think we can use half an hour for this exercise, and after that I will explain domain models, and then we will have another half an hour for working on domain models. And then after finishing with the second exercise, then you will have an opportunity to give presentations. And I will then comment, and I will then be trying to help you. So I know you are all working, but will you excuse me if I actually explain one more kind of model? Like for 10 minutes or so, and then you can continue working. Because we have the time pressure, I would like to finish the analysis stage today, so that tomorrow we can start dealing with more technical things. I mean, the plan is actually to talk tomorrow about how roles, these pretty abstract roles from the analysis stage, can be mapped to more concrete agent types from the design stage. So this is the way how we're going to move from analysis to design. And then I'm going to talk about acquaintances between these different types of agents, interactions between agents, and behaviors by agents. And I will finish the course by talking about and providing examples on prototyping of socio-technical systems. So I will then now discuss domain models, which actually lie to the battery problem. Yep. Ah, okay. Yep. So the domain models which lie in the information column at the analysis layer. So, and the purpose of domain models is to represent the knowledge that is to be somehow represented in the system. Because always when we talk about an information system of any kind, then we always need to represent knowledge about something or somebody. And as the first stage, we need to capture that knowledge at the analysis stage by using domain models. So I think the closest relative to domain models is class diagrams of UML. But it's not quite the same, but it is similar. And I will explain soon how and why. First of all, there is one concept that we haven't covered yet, and that concept is relevant for domain models, and it is the concept of a domain entity. So what is domain entity? So a domain entity is a modular unit of knowledge handled by a socio-technical system. So domain entities may be viewed as object types. You are all at least those with ICT background, you are familiar with object types of UML or classes of UML. So domain entities are very similar, but we view them in a bit different context. So we view them in the context of a socio-technical system as a whole. And the question we ask is what kinds of knowledge should be represented within that system as a whole. So we do not address yet individual components, individual parts of the system, but we are talking about the system as a whole. So what knowledge do we need to represent? And only later at the stage of design, we're going to deal with the individual parts, components of the system, and what knowledge do they need in order to be functional. So, and what do I mean by modular unit of knowledge? So I mean that knowledge about, for example, talking about a case study of business-to-business electronic commerce, I mean domain entities like request for quotes, quote, order, confirmation, invoice, payment also. So these kinds of domain entities. Or talking about healthcare information systems, so there can be domain entities like patient, describing a patient, condition or disease, describing a particular condition or disease, or for example, referring to that case study of a socio-technical system for pregnant women, there can be a domain entity like pregnancy describing the particular pregnancy of a particular person. Or there can be domain entities like insurance coverage, about this case study of insurance, and also a domain entity describing a customer in that insurance case study and in many other case studies. So basically they are classes or object types that, that represent some knowledge that is relevant for the system that is being designed. And here is the kind of official definition for the domain model. Domain model represents the knowledge within the system that the system is supposed to handle. And the domain model consists of domain entities that I just explained and relationships between them. So, did you now remember what was domain entity? So this I deliberately put this question mark here. Sorry? Unit of knowledge, exactly. Unit of knowledge, yes. And a domain model also, in addition to representing relationships between different domain entities or between different units of knowledge, a domain entity also relates, domain model also relates domain entities to roles. And this means that in a domain model we represent, how is a domain entity, how a role, for example, consumes a domain entity, or how does a role change a domain entity? Of course, it's not a role. It's, at the end of the day, it's an agent playing the role. Some human agent or some software agent or some other software entity playing the role that changes the domain entity. But here at the analysis stage, we model it in terms of the relationships between roles and domain entities. Examples are, for example, that a buyer in a business-to-business electronic commerce changes their role, changes the domain entity of request for quote, or seller changes or creates and changes the domain entity of quote, or insurance changes the domain entity of insurance coverage. So things like that. I'm not going into more details here. Basically a resource is a kind of a domain entity, and it is relevant in some case studies, like in the case study of Tamagotchis, where a Tamagotchi consumes different resources, which are of course information resources that simulate real physical resources like food or present or some games or some toys. But this is not so relevant right now because of our schedule especially. So here is an example of the domain model for the case study of Tamagotchis. And it's actually just a part of the domain model. But what we represent is we represent domain entities like present and relationships of these domain entities to roles. Like here you can see my Tamagotchi gives a present, and friend Tamagotchi, this is the role of my friend's Tamagotchi, receives the present. And here the owner, the role of owner, interacts with my Tamagotchi. Of course, this is a part of the organization model. So the domain model is here. But occasionally it's good to represent also some parts of an organization model in a domain model, like is done here. And we can also represent the environments if relevant in our domain models, like in case of this Tamagotchi example, Tamagotchi town and the local environment, Tamagotchi shell. But this is, I don't think it's so relevant for your case studies here, your product ideas. Here is the domain model for grocery shopping. And what we can see here, first of all, we can see here different domain entities like shopping list. Then there is a shopping basket. There is product information for each product. The product information, its instances describe different products. The instances of this object type or class describe different products. Then there is a store location describing whose instances describe the locations of different stores. There is a fuel cost also, and which varies, of course, and this should be reflected by the system. This varying of fuel cost on a marketplace. And then there are roles. Actually, there is just one role here. This is a simplified domain model. There is the role of assistant. Assistant is the role of someone or somebody helping the customer, as you remember from the last session. And now we represent the relationships between this role and domain entities. So the assistant creates a shopping basket. When creating a shopping basket, the assistant considers a shopping list by a customer, because the customer should actually provide the assistant with a shopping list. Then shopping basket is based on the shopping list. Then assistant also considers product information when making recommendations to the customer. Assistant considers the locations of stores when planning the route for a customer, and assistant considers fuel cost when planning the route. And fuel cost, on the other hand, is based on locations of stores. Because this is obvious. The more one has to drive, the more expensive it is. So we represent the relationships between domain entities, like here, shopping basket is based on shopping list, or fuel cost is based on store location, and we also represent the relationships between roles and domain entities, like, for example, assistant creates shopping basket, or assistant considers a shopping list. And I will show you also an elaborated domain model for grocery shopping, because that was a simple version. And this is here. So as you can see, there are more domain entities here, like, for example, a typical shopping list, or like, for example, route, or like, for example, store information, not just store location, but more information about the given store. And there are also more relationships, like, for example, the relationship calculates between the role assistant and the domain entity's route and fuel cost. But it's basically quite similar, but it is more elaborate. So the only difference that there are more domain entities, more roles, and more relationships here. For example, the simplified version didn't have the roles of customer and didn't have the role of store either. So was this clear? So but basically, we need to represent the knowledge for the system as a whole, and we do it by using these kinds of domain models. And why do we use these models is because they are simple, and they are simple because they are meant to be used for interactions between non-technical people, stakeholders, customers on one hand, and technical people like designers and software engineers on the other hand. So, and this is true for actually all kinds of analysis models, for goal models, role models, organization models, and domain models. And now another exercise, and actually feel free to combine these exercises during the remaining half an hour. So, and this is about creating a domain model for the product idea of your team. Here you can use the Microsoft Visio stencils if you wish to use them, or an A1 paper. And time allowing, continue working on your goal model, role models, and organization model. So what I would like to see at the end of the today, maybe not today yet, but at least by the end of the week, our goal model for your product idea, along with related roles and quality goals, then role models, organization model, and a domain model. And tomorrow, as I said, I'm going into design models, and would be very good if you could also actually create at least some design models by the end of this week. But we will see tomorrow how is it going. It's becoming a bit more technical, but not too technical, I can promise, to the relief for, I think, some of you, but maybe to the disappointment by some others who have more technical stance. But we will see how we go, and I promise I will be flexible and will try to react to this particular audience. So thank you for your attention, and then now there will be half an hour for independent work, and I will be around. Feel free to ask questions anytime, and then starting at 3 or so, I actually expect to hear your presentations, and of course I will try to be useful and give feedback. So thank you.